Dear students, welcome to the lecture series on graph coloring. Graph coloring, as you all know, is a part of the discrete maths syllabus which is taught in the undergraduate level of different schools and universities. So before I talk about the course content or the content of the lecture series, I will first try to explain in a very layman's term what graph is all about and what graph coloring is all about. So first, coming to graph, what is a graph? So when we talk about graph, we talk about a set of vertices which we generally name as V1, V2, V3 or similar kind of way, and a set of edges which basically connects the vertices. So this is a graph. We represent it in a way G equals a combination of vertices and edges. Sometimes we also assign weights to the edges, but sometimes we do not do it. So why do we need graphs? What do we need graphs for? Say when we have different entities and we want to represent the entities and the relationship between the entities, the simplest way to do that is using graphs. How? Let's take the example of, say, we want to color the map, the different states in the country, we want to color in the map. Okay? So what are the entities here? The states in the country. Okay? So let me draw the map first. So I can draw it as something like this. There are, say, 4 states. There is a state 1, there is a state 2, there is a state 3, and there is a state 4. So I can have a graph as edges, as vertices S1, S2, S3, and I have a S3 here and a S4. So these are the 4 vertices of the graph which represents the 4 states. I still don't have the edges. I have to find it out. But before that, what should come as the edges? That is something that I need to decide on. Basically, the states share a common boundary, right? So like S1 and S2, S1 and S3, S1 and S4, they share a common boundary. So that can be represented as 3 edges. So between S1 and S2 there will be one edge. Between S1 and S3 there will be an edge. Between S1 and S4 there will be an edge. Right? Now I move to the state 2. I have common boundaries between S1 and S2 which is already being captured in the graph, and between S2 and S3 which I draw as another edge. So that is done with the S2. Then I come to S3. So I come to the S3 vertex. S3 shares a common boundary with S2, S4 and S1. So S3 with S2 is already there. S2 with S1 is already there. I have one more boundary or one more edge between S3 and S4 drawn here as an edge. So this actually is the graphical representation of the states in a specific country, the 4 states in a specific country, and the relation between the states in the form of common boundaries they share. Okay, and that is being expressed as the edges. So what are the edges like? We can call them out as or name them as E1, E2, we have a E3, E4 and a E5. So this is the graphical representation. This is a graph G which represents the scenario of 4 states in a country and the boundaries they share. So this is all about how graphs can be used to represent the real life context. Now coming to the graph coloring. What is graph coloring about? What does graph coloring say? The first principle of graph coloring is it needs to find out the adjacency. Adjacency between what? Adjacency between the vertices when we are talking about vertex coloring. So first of all, the graph coloring can be of three types. It can be either a vertex coloring, it can be a edge coloring, and in case of non-planar graphs, it can also be a face coloring. Okay, so face means in a non-planar graph, the faces will be represented as a different color. Now, talking about adjacency, when do we call two vertices to be adjacent? When there is an edge between two vertices, like here we have an edge between S1 and S2, that is adjacency. We call the vertices S1 and S2 as adjacent vertices. The fundamental principle of graph coloring says that if there are two adjacent vertices, we have to color them in different color codes so that we can differentiate the vertices. So I color one of them with a green and the other one with a violet. Okay. In the same way, we can also think about edge coloring. Two edges are said to be adjacent when there is a common vertex between them, and also face coloring when there is a common edge between two faces. We can tell that as a adjacent face or adjacent faces. Now, this is all about graph coloring. So we can have three types of graph coloring, but in this lecture series, we will be focused more on the vertex coloring. So whenever we tell graph coloring, we will actually mean the graph vertex coloring. Okay, so whatever problems we will be solving or whatever theorems we will be talking about, it will be all related to the vertex coloring. That's one thing. What all things are we going to cover? So first thing is, I will talk about one specific motivating example. So map coloring is one of them. I will complete this and also take another example. And using that example, I will tell you what is the way to use different graph colors and solve problems. So that's the thing I'm going to start with. And then in that context, I will familiarize you with the different terminologies like chromatic polynomial, what is that? Or a chromatic number, what is that? So I will introduce those terms to you. And in terms of the theorems, I will also talk about the different theorems which exist in the different areas. When we solve the problems, we will have to actually use the theorems and solve the problems. So I will be touching upon the theorems, specifically the very important theorems related to the upper bound and the lower bound of the chromatic number. So specifically like Brooks theorem is one of them, Zachary-Swift theorem is another one of them. So I will talk about those theorems. Then what I will do is I will move on to the chromatic polynomial. What is a chromatic polynomial? How do we work out, how do we derive the chromatic polynomial for the different graphs, the standard graphs as well as the general graphs? So I will talk about that. In that context, I will also talk about the decomposition theorem and how that is used to solve or to derive chromatic polynomials. So I hope that the next few lectures in this series will be quite interesting and informative for you. Stay tuned. Thank you.